For this question, the important point to recognize here is that we are not given the measure of this angle. Even though it looks like 90 degrees, we can't assume this. So this angle could be very small, in which case the length of AB is much shorter than the length of AO. In this case, column A would be greater than column B. However, the same angle could be very large, in which case the length of AB is greater than the length of AO. So as you can see here, we can't definitively determine which column is greater, so our answer is D.
A cylinder has a surface area of x square inches and a volume of x cubic inches. Now this might seem confusing for some of you. How can an area be equal to a volume? Now all this means is that the numerical part of the surface area is equal to the numerical part of the volume. Of course, they have different units. So if the circumference of the cylinder's base is equal to 10 pi, what is the height of the cylinder? A cylinder is defined by its radius, that is the radius of the circular faces, and its height. The volume of the cylinder is given as the area of each circular face, that is pi r square, multiplied with the height of the cylinder, and the surface area of the cylinder is given as the area of the two circular faces, that is pi r square plus pi r square, which is 2 pi r square, plus the circumference of the circular faces, that is 2 pi r, multiplied with the height of the cylinder, which is h. And in our problem, this circumference, 2 pi r, is given to be equal to 10 pi. So that's 10 pi. And if we set 2 pi r is equal to 10 pi, we get r is equal to 5 inches. So now we have the radius of the cylinder, that's 5 inches. Let's come back to the problem. The surface area is x square inches. The volume is x cubic inches. They're different physical quantities, no doubt, but the numerical part of the surface area is equal to the numerical part of the volume, and therefore we can set these two equal. So we have pi r square h, and r is 5, so that's pi times 5 square times h is equal to 2 pi r square, that's 2 pi times 5 square, plus this portion is 10 pi times h. That's 10 pi h. We can divide both sides with pi, that is take out pi from each of the terms, so that we have 25h is equal to 25 times 2, that's 50, plus 10h. You want to get the h on one side, so subtract 10h from both sides, and we have 15h is equal to 50, and therefore h is equal to 50 over 15, which can be simplified. 50 divided with 5 and 15 divided with 5 gives us 10 over 3. So that's the height of the cylinder, option E.
Okay, to begin, please recognize that it's possible for our angles down here to be equal to 90 degrees each, in which case our remaining two angles would be equal to 60 degrees each. From here we can see that we would have two identical triangles, in which case the length of side AB would equal the length of side BC. Now consider side DC here. We could make this side shorter without affecting the 30-degree angle there. As such, we would create a new triangle where side AB is longer than side BC. So since we cannot definitively determine which column is greatest, our answer here must be D.
The right triangle ABC has side lengths 10 minus x, 9 minus x, and 8 minus x. Given that only one value of x is possible, I'm going to underline that because it's probably important, which of the following statements is true? And then we have our list of statements that we need to evaluate here. Now, before we get going with this problem, I'm just going to point out that right triangles are one of the most important shapes to know for this test, maybe even one of the most important topics to know. And the reason for that is they're tested very frequently, and they have plenty of rules to know. So if you're not completely solid on right triangles, my advice is to go back and watch the right triangle lesson. Okay, with that said, let's attack this problem. So we have our right triangle here, and we have the lengths 10 minus x, 9 minus x, and 8 minus x. How do I know, by the way, that 10 minus x is the hypotenuse of this right triangle? Well, because it's the longest distance. 10 minus some number is bigger than 9 minus the same number is bigger than 8 minus the same number. So 10 minus x is the hypotenuse of this triangle. And if you see the words right triangle, you probably immediately think of a certain theorem, which is the Pythagorean Theorem, right? Everyone say it together. A squared plus b squared equals c squared. Something you absolutely need to know. So if worst came to absolute worst, what we could do is take each one of these values and plug it in to the Pythagorean Theorem. We got our a, our b, and our c. And we're going to do that, right? We're going to do this the long way, but then we're going to talk about a fun little sneaky shortcut that we can use for this. So if we plug these values in, here's what we get. We get 8 minus x quantity squared plus 9 minus x quantity squared equals 10 minus x quantity squared. And before we proceed any further, I'm just going to point out that we can get rid of a couple of answer options here. For one thing, I can get rid of c. ABC is not an isosceles triangle. I could have told you that right away, right? Because 10 minus x is not the same as 9 minus x, is not the same as 8 minus x. An isosceles triangle has two equal sides. This one does not, so C is out. Furthermore, if I solve this out, right, it will be messy, but we're going to do it together. If I solve this out, I will get some answer, right? And I know that there's one value of x that works. So I will be able to find the area. So I can get rid of D, right? I will be able to find the area eventually, even if I do mess up, I know I can get rid of D. All right, so let's FOIL this out, and I'll encourage you to pause the video right now just to practice your own foiling. And if you're rusty on foiling, go watch the foiling lesson. Okay, ready? Pause. And we're back. Okay, let's FOIL this out. 8 minus x quantity squared gives us what? 64 minus 16x plus x squared. How about 9 minus x quantity squared? What does that give us? 81 minus 18x plus x squared. And all that equals 100 minus 20x plus x squared. Okay, now we need to combine like terms. Again, go ahead, feel free to pause the video, do this on your own. And what do we got? We got 64 plus 81, and then we're going to subtract 100 from both sides. So let's do that. What does that give us? It gives us 45. And then if we combine negative 16x and negative 18x, and then add 20x to both sides, there we go. Then we're going to end up with negative 14x on the left side. And then we combine x squared, 1x squared plus 1x squared, and then subtract x squared from the other side, and we're left with x squared. All that equals 0. Okay, and we're not done. Now we have a quadratic. If you're not completely comfortable with factoring quadratics, that is something else to review. But let's do it together. What's the game here? We're looking for a number that multiplies to, or excuse me, two numbers that multiply to 45 and add to negative 14, right? So it's probably going to be negative. I got 45, and I want two numbers that multiply to that and add to negative 14. How about negative 15 and negative 3? Does that work? No, it doesn't add to negative 14. How about negative 9 and negative 5? Oh, there we go, right? Negative 9 plus negative 5 is 14, and those two multiply to 45. So I can then write this in the factored form, x minus 9 times x minus 5 equals 0. And then I solve my quadratic. I just say, or excuse me, I solve for x. I just say, okay, well, x has to equal 9 or 5. But wait, the problem told us there's only one possible value of x. One of these values is not possible. And think about that. If x equals 9, let's bring it back to the problem over here, then 10 minus 9 is 1, 9 minus 9 is 0, and 8 minus 9 is negative 1. I can't have a triangle with a leg of negative 1. So 9 as an answer is eliminated, right? So x has to be 5. And if x is 5, then I'm going to plug it in to the expressions here. 10 minus 5 is 5. 9 minus 5 is 4. And 8 minus 5 is 3. So 3, 4, and 5. X certainly is an integer. And the perimeter of ABC does have to be greater than 10. 5 plus 9 is, 5 plus 4 is 9, plus 3 is 12. So the correct answer is B. Now, all that's well and good, but let's talk about a quicker way to do it. It's good to go over the math every now and then. But here's the quick way to do it. If you are a right triangle pro, then you know your Pythagorean triplets. What are those? Well, those are groups of 3 that fit in the Pythagorean theorem. So, for instance, the most famous one is 3, 4, 5. Right? You probably know that one. Or 6, 8, 10. That's an outgrowth of 3, 4, 5. 5, 12, 13 is another famous one. And 7, 24, 25. If you need a review of this, again, take a look at the right triangles lesson. All right, well, what do we know about this? We know that there's only one value of x, right? There's only one arrangement. And we also can notice that these 3 sides are 1 apart from each other. 10 minus x is 1 greater than 9 minus x, which is 1 greater than 8 minus x. So the only possible arrangement of sides would be 3, 4, 5. That's the only Pythagorean triple that works in this case, right? And it works perfectly because 8 minus 5 is 3, 9 minus 5 is 4, and 10 minus 5 is 5. So the only possible arrangement to have a Pythagorean triple where they're 1 apart, that gives me a right triangle, would be 3, 4, and 5. So I can skip all the math and jump right to answer option B, i.e. the perimeter is greater than 10.